Today we're going to talk about what is called the magic hexagon. The magic hexagon was invented by a mathematician over 100 years ago, but it is very helpful in remembering some basic trig identities that you will need in calculus class. So, as we begin, the first thing we're going to do is draw a hexagon. In the center of the hexagon, you need to put a number 1 and circle it, and then have a line going out to each of the vertices of the hexagon. The reason a hexagon is used is because a hexagon has 6 sides and there are 6 trig functions. And so each of the trig functions will be labeled on one of the corners of the hexagon. It is very important that the corners are labeled properly so that the hexagon will generate the identities that you need. So, when it comes time to labeling the vertices, you need to think about, if someone asked you, what are the 6 trig functions, what order would you list them in? Now, most people, when I ask this in class, would say this order: sine, cosine, tangent, cotangent, secant, and cosecant. Now, this is the order that we are going to list them on the hexagon, not going around the outside, but going across, like you were writing a paper. So we're going to take each horizontal line and we're going to put the 6 trig functions on in order. We start at the top left. This will be sine, and this one will be cosine. Come down here, this is tangent, cotangent, at the bottom secant, and cosecant. Notice that when you're done, the 3 main trig functions are on the left, their co-functions are on the right. That will make sure that you have everything in its proper location. Now let's talk about the categories of identities that the hexagon will help you remember. The first category is the reciprocal identities. A lot of times in calculus, you're trying to think, now, which trig function is the reciprocal of the other? Does sine go with secant? Does cosine go with cosecant? The hexagon will tell you. Let's list the 3 main ones that everybody remembers. Secant, or should remember actually, secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is 1 over tangent. Now, looking at the hexagon, do you see where these are? As you will notice, each of the reciprocals are on a diagonal across from each other with the 1 in the center. So, secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is 1 over tangent. Now, there are 3 other reciprocal identities. They just go the other direction. Tangent is 1 over cotangent. Sine is 1 over cosecant. And cosine is 1 over secant. So all 6 of them are there. We just listed the main 3. So just always remember, if you label your hexagon properly, the reciprocal trig functions will be directly across from each other. Now, the second group are the quotient identities. Now, there are mainly 2 of these, and a lot of times students tend to remember these. Tangent is sine of theta over cosine of theta, and cotangent is cosine of theta over sine of theta. Now, look at the hexagon and see where these are in relationship to each other. Tangent equals sine over cosine, so they're following a path along the outside of the hexagon. Cotangent equals cosine over sine, so the cotangent identity is actually going in the opposite direction. These are the main 2, but actually you can start anywhere on the hexagon and create a new quotient identity if you wanted to. For example, you could say cosine equals cotangent over cosecant, or you could say cosine equals sine over tangent. And that's a proper quotient identity as well. So there are many, many quotient identities. They all go along the outer edge. So these are the outer edge, and these are the diagonals. The third and final set of identities are the Pythagorean identities. And as you might as well guess, these come from the Pythagorean theorem. Now, the Pythagorean identities are actually a little more embedded in the hexagon. As you notice, there are 6 separate individual triangles here. We are looking specifically on the triangles where the bases are at the top. So we're looking at this triangle here, this triangle here, and this triangle here. Now, the first Pythagorean identity is the 3 corners of this triangle right here. And it is the first corner squared plus the second corner squared equals the bottom corner squared. So our first identity is sine squared theta plus cosine squared theta equals 1 squared, or just 1. Go to the second triangle right here. Same procedure. Tangent squared plus 1 squared equals secant squared. Tangent squared plus 1 squared equals secant squared. And then finally, this triangle over here has the third one. 1 squared plus cotangent squared equals cosecant squared. So 1 squared plus cotangent squared equals cosecant squared. Now, those are the 3 main identities that we're looking at. But a lot of times we will see the identities where they're rearranged, where it's not sine squared plus cosine squared equals 1, but it might be 1 minus sine squared or 1 minus cosine squared. The way those work is starting at the base. If you take this one here and subtract this one squared, you get this one squared, or going the other way, this one squared minus this one squared equals that one squared. So we have, starting at the bottom, 1 minus sine squared equals cosine squared. 1 minus sine squared equals cosine squared. Or 1 minus cosine squared equals sine squared. 1 minus cosine squared equals sine squared. Okay, let's take the second triangle, this one right here. We would start at the bottom. So that would be secant squared, let's go to the left, minus tangent squared equals the third corner, 1 squared. And then the other variation would be secant squared minus 1 squared equals tangent squared. And now finally, the third triangle right here. We're going to start at the bottom. So this would be cosecant squared minus 1 equals cotangent squared. And then going the other way, cosecant squared minus cotangent squared equals 1. And there you have it, the magic hexagon and all of the identities that are embedded with it. There are actually many more. The cofunctions are embedded in it. We didn't talk specifically about those, but these are the main ones that you're going to need for calculus. So anytime you are dealing with an exam where you're having to remember trig functions, if you can just reproduce this drawing, you can recreate these identities.